Okay, calculus, here is a fun indefinite integral for you. Remember, the elongated s means antiderivative. So we have two terms here. We have this big long mess, 0.3 times the x to the fourth times the cosine of 0.02 x to the fifth minus 0.05. And then we have the second term right here. So remember your three antiderivative options. You have the power rule, you have u substitution, or you have your flashcards, the ones that you just know. So this first term is going to be u substitution because there is an outer and an inner function. So this is going to be u sub, and over here on the end, this is just going to be an easy power rule. So we are going to go off to the side here, and we're going to get down below, I guess, and we're going to take that first term, and we are going to write out our u substitution steps. All right, so let me get this all in here. 0.02 x to the fifth minus 0.05 dx. So again, I'm just taking this first term right here, and I'm going to use u substitution. So when we do u substitution, u is always our inside function, and the inside function is right here. So right here, this is what I'm going to make my u equal to. All right, so here we go. First step, u is equal to 0.02 x to the fifth minus 0.05. Now we go to the second step of u substitution, and of course, u becomes du. We take the derivative of this. The derivative is the power rule here, 5 times 0.02 gives me 0.1. And then if we subtract 1 from the exponent, we get 0.1 x to the fourth. Okay, the derivative, of 0.05 is just 0. So once again, we need all three parts. U becomes du. We take the derivative of this and get this, and then we toss dx on the end. Okay, now we're going to go up and we are going to diagram. All right, this piece right here is going to come along for the ride, so we're not going to worry about that. This piece here is going to become the cosine of u because we know the antiderivative of that. So now we ask ourselves, what is left? What is left is x to the fourth dx. Whatever is left after you plug in u has to be by itself right here. So we need x to the fourth dx all by itself right here. So we just need to divide by 0.1. Okay, if we divide by 0.1, I'm going to divide this by 0.1, and I'm going to divide this by 0.1. If I break this down into steps, there is a 1 here, even though it's not written. So that becomes 1 over 0.1 du. Here the 0.1's cancel, and I have x to the fourth dx. All right, now finally, I want to simplify this guy because I don't want a decimal in a fraction. So 1 divided by 0.1, of course, gives me a nice easy number. 10 du is equal to x to the fourth dx. Okay. Now, that was the third step right there, is our new and improved differential. The fourth step now, of course, is to rewrite our integral using only u's and du's. So again, the big elongated s comes along for the ride. 0.3 is going to come along for the ride. Okay, this piece here is going to get replaced with the cosine of u. And then I'm going to replace x to the fourth dx. Right here, x to the fourth dx is going to be replaced with 10 du. Okay, so again, the elongated s comes along for the ride. The 0.3 comes along for the ride. This whole piece here is getting replaced with the cosine of u, and x to the fourth dx is getting replaced with 10 du. That is my fourth step. Okay, now I'm finally ready for the fifth step, which is to actually take the antiderivative. All right, so 3 things are going to happen. Something needs to come along for the ride. So this is going to come along for the ride, and this is going to come along for the ride. So 0.3 times 10, that's going to come along for the ride. The notation, of course, is going to drop out because I'm going to be taking the antiderivative of this one thing. That's the one thing I need to take the antiderivative of. The antiderivative of cosine is just sine of u plus c. All right, finally, 6th step. We multiply the 0.3 and the 10, and we just get 3 sine of u. And now we plug in u, so that is 0.02 x to the 5th minus 0.05. So this right here is the antiderivative of that first term up here, right here. This whole first term, the antiderivative is right here. Now we add in the antiderivative of 7 using the power rule. So the antiderivative of 7 is just plus 7x, and then, of course, plus c. There we go. There's our antiderivative.